In this video, we're going to look at numerical data and how we can start to work with it, from displaying it to making calculations that'll help us understand our data better. So for starters here, we're going to look at what's called a dot plot, and the example that we're constructing this dot plot for, it gives us a frequency table of particular variable values. So what we have here is the heights of 127 choir members, and these heights are, rounded to the nearest inch, and then they're just recording for us how many, right? Remember, frequency is how often of each height we have. So there's 2 people who are 60 inches. There's 7 people who are 61 inches. And while this frequency table is really helpful, it would be nice to have a visual representation of it. And that's what a dot plot is. So a dot plot will just put along the x-axis your variable value, and then just put a dot for every time that variable value shows up. And this is really helpful because here, you can kind of look through this frequency table and see that, right here is a peak. And then we have another peak later on here. But it's much more obvious when we have it in dot plot form, where we say, oh, okay, here's a peak and here's a peak. Now, just to kind of start thinking about gaining some meaning from data, I want you to think for a moment about what it is that is causing 2 distinct peaks in the data. Well, if we think about what might be causing it, let's understand these values here of 65 and 66 for that first peak is, well, translating that into feet and inches, that's 5 feet, 5 inches, and 5 feet, 6 inches. This here is 5 feet, 11 inches, and 6 feet. And so if you think about these heights, these are fairly typical heights for here females and here males. I think average height for females is like 5'5". So we're getting these peaks where in the population we would expect to see lots of people of that particular height. Okay, so actually let me go back to the slide for 1 second. What made that dot plot possible is that there weren't too many different variable values that I had to worry about. 60, 61, 62. Remember we talked about discrete numerical variables where there's specific jumps between possible values. What if we don't have lots of repeats like we do in this data set? So here's a data set that looks at the ages of 34 recent Academy Award-winning actors. So here's the raw data here, and to kind of organize it, a frequency table is built. But this one's a little different. Rather than saying we have this many people at age 30 and this many people at age 31, they make groups. And that's because there's very few repeating numbers in this data set. So in order to get those frequency numbers high enough that they would give us some meaning, what we do is count how many times a particular interval of numbers shows up. So we kind of end up with a very similar looking frequency table to what we had in the last problem, but it's an interval of numbers, right? There are 5 people between the ages of 30 and 35. There's 7 people between the ages of 35 and 40. And so rather than putting individual dots, we're putting bars, and the width of the bar is going to go from this number to this number, right? So, this is, of course, 35, right? And this is, of course, 45. So between 30 and 35, I have 5 of the actors, right? 35 and 40, I have 7 of the actors. So we get that same sort of information. We can see where is there lots of data, where is there less data, just like we could with the dot plot, but this helps us when there's not lots of repetition in our data. All right, so to kind of get a handle on this, here's an example, and when we're in person, I like to actually survey the class and kind of find out how much they sleep. And here's kind of maybe what would be a typical response when I do ask that in class. And so let's just suppose that I asked a class of 25 students how much sleep they tend to get, on a weeknight, and I get the following. One student gets between 4 and 5 hours of sleep. 7 students between 5 and 6, and so on. So just a little bit of an exercise here to go back to an idea that we already learned about, which is relative frequency. Right? Remember, relative frequency, the word relative means we're comparing it to something. So compared to the total, right, how often are we getting between 4 and 5 hours of sleep? Well, that's one student out of 25, right? And when I punch that in my calculator, we get 0.04. 7 people out of 25 is 0.28, right? So remember, that means 28% of the class, in this case, gets between 5 and 6 hours of sleep. 8 out of 25, 0.32. 6 out of 25, 0.24. 2 out of 25, 0.08. And we get 1 out of 25 again. And then, of course, 0 and 0. Right? So those are our relative frequencies. Then finally, cumulative relative frequency is something that we'll also keep track of at times, and that just means you add as you go. And the fact that you're adding as you go, and knowing that ultimately the percent in each category should end up being equal to 100% when we add them all together, we know at the end of this I should end up with just 1 or 100%. So for the cumulative, means just we're adding up as we go. We just start with the first one, 0.04. And then we go ahead and we say, all right, let's take 0.04 plus the value from 5 to 6. And so that means we're at 0.32. So what that tells us is that 32% of people are getting 6 or fewer hours of sleep. Then I take the 0.32 and I add the 0.32 from this category. So I know now that 64% of people get less than 7 hours of sleep. 64% of students in my survey, that is. Oops. All right, and then we'll just add that next one as well. Fix that typo. So just adding all these up. And just as expected, once we add up the proportions of from each of the number of hours of sleep, we get up to 1 or 100%. All right, so now let's do some stuff with this chart that we've made. Let's create our own histogram, okay? And so what I'd like you to do is pause and try to make your own histogram. Take a peek at the last page if you need to for guidance, but create a histogram based on this data that we just made. All right, so in a histogram, right, we need both an X and a Y axis. Okay, so make a Y axis there. X-axis, and it's really important to remember what the X-axis is doing, what the Y-axis is doing. So my X-axis is keeping track of my variable values, right? And one thing I actually want to do, and I did a bad job of this, but this is just a good teaching moment, is my X-axis is not going to start at 0. There's no reason to start it at 0 and go all the way up to 4 necessarily. So what I want to do is I want to not necessarily begin right at, I don't necessarily want to link my x-axis up with my y-axis necessarily. So it's good to have a little bit of a space so that it's alerting our reader to the fact that this isn't like a traditional 0, 0 point here. Okay, so then we can go ahead and start, here's 4, 5, 6, 7, 8, 9, and 10. And so this is our variable value, and I did a bad job of leaving myself enough room. This would of course be hours of sleep, right? Always label your x-axis. Then our y-axis, right, is the frequency. And so for the frequency, we know that we go from 1 up to 8 is the highest. So that means as I make my tick marks here, 1, 2, 3, 4, 5, 6, 7, 8. Whenever you're making graphical displays, you want to make sure that you're thinking ahead of time about, okay, how much should I space my tick marks out, given the fact that I need to get all the way up to 8. Okay, probably be unnecessary to put 20 tick marks here in order to represent this well. So you want to think about kind of what that maximum is when you think about spacing. So this is our frequency. And you don't always have to label each one of them, maybe even just labeling that as 8 so that we know that this is, each of these tick marks represent 1. And then we're just making those bars from that last page. We call those bins, by the way, to use the proper term. So this first bin that goes from 4 to 5 is just going to go up to a height of 1. The second bin is going to go all the way up to a height of 7. Because 7 people get between 5 and 6 hours of sleep. This one's going up to 8. Then we've got, and of course I'm freehanding this, so this isn't quite as pretty as I'd like. Between 7 and 8 is 6 people. Between 8 and 9 is 2 people. And between 9 and 10 is 1 person. So there's my histogram. Okay. Now we're also going to work a lot with what we call relative frequency histograms. And that's just simply same idea as a histogram, but we're going to use relative frequency when we look at the y-axis instead of the frequency, or how many times something happens. So a relative frequency histogram, go ahead and put together here. Okay. So again, we'll start with 4, 5. So this doesn't need to change at all. Again, this is hours of sleep. And here, this is the relative frequency. So what we're just simply doing is, instead of keeping track of how many times it happens, we're keeping track of the proportion of the time each thing happens. So as I count up here, I need to get up to 0.32. All right. Well, 0.04, 0.08. We'll put some labels on there so that we know what each of these represent. And again, you don't have to put too many labels on, but 0.04, 0.08, 0.12, 0.16, and hopefully your histograms look a little better. I didn't leave myself quite enough room here. But then I can go ahead and just use the relative frequency. So up 0.04 between 4 and 5, up 0.28 between 5 and 6. And so not surprisingly, as we're constructing this, we can see the exact same shape is coming about as for our frequency histogram, for our relative frequency histogram, right? Same exact shape. It's just simply that the y-axis is representing something different. Now, sometimes that you're going to look at a histogram, maybe in the textbook or really anywhere, and you're not going to necessarily have it labeled as a relative frequency histogram, but just understand that how do you know what you're looking at? Well, it's definitely a relative frequency histogram if you're looking at decimal values here, or percentages, right? If you're looking at these just whole numbers, then it's a regular histogram. All right, part B asks us, what is the most frequent response? Well, in this case, the most frequent response was between 6 and 7 hours of sleep. So that's what's referred to as the mode, between 6 and 7 hours. All right, part C then says estimate the amount of sleep that is in the middle of the data. In other words, if we lined the class up from who gets the least amount of sleep to who gets the most amount of sleep, if we picked the person in the exact middle, so that'd be the 13th person, how much sleep are they getting per night? Well, that's something we can figure out, and we can use the cumulative relative frequency to help us, right? So what did we say? 32% of students get 6 hours or fewer of sleep. 64% of students get 7 hours or fewer, right? So 32%, 6 hours or less, and 64% get 7 hours or less. So when I'm looking for the median, I'm looking for what's in the middle, where I'm looking for 50%, right? So that means that 50% get somewhere, right? Half get somewhere between 6 and 7 hours of sleep. And so our median is just simply that, somewhere between 6 and 7 hours. So our median is somewhere in there. So the median, or if you'd like, the middle of the data, right, is what the median is. All right, so to kind of explore this idea of the median just a little bit more, kind of have a little bit of a silly example here. It says, suppose that a small business owner has 4 employees that he pays $8 per hour. The owner pays himself a stipend of $28 per hour and puts all other revenue into expenses and investing back into his business. Suppose that he wants to hire another employee and advertises in the paper that the average wage for those working at his business is $12 per hour. Is this true? Yes, that's true. And the reason that that's true is we know that we compute average by adding up. So 8 plus 8 plus 8 plus 8 plus 28 divided by 5 does in fact equal 12. So that's true. But is it misleading? Yes, it's also very misleading. So what this tells us is that average, the mean, is not always the best measure of center. Okay? Mean isn't, and we'll just make a little note here, mean isn't always the best measure of center. And my pen just keeps having trouble here. The best measure of center. In this case, because of what we would consider an outlier here of 28, the median is actually better. Why? Because the median of this data set is equal to $8. And that's going to give a prospective employee a much better idea of how much they can expect to make this business as opposed to the mean. Just one other example here. So I'm sorry, I guess that was supposed to go there, wasn't it? Find the distance in feet ran in 5 seconds by 8 preschool children. Find the median of that data set. So 6 seconds, 10 seconds, 13 seconds, and so on. So it wants us to find the median. So whenever you're finding the median, the first thing to do is always put the data in order, right? So reorder it. 6 goes first, then the 8s. Then I have 10, then 11, 11, 12, 13. Okay, now when we found that the median was $8 for the small business example here, that was because if I listed those out in order, it was very clear that the middle of the data was that one. Here it's a little interesting because we have an even number of data points, and so there is no middle here. There are 2 middle numbers, right? So whenever you have an even number of data points, even number of data points, that means you have kind of 2 middle numbers. And you're going to average the middle 2. So 10 plus 11 over 2, so just halfway between them, 10.5 seconds is the median. So it's okay for a median to not actually be a value in the data set. That's fine. And so in this case, it's 10.5 seconds because we're just splitting the difference between the middle 2. So this idea of a median leads us into the next topic, which is that of percentiles. Okay, so a percentile is simply the percent of the data set that is below that value. Okay, so for those of you who have kids, a really common way that you hear about percentiles is when you take your child to the pediatrician and they measure the height, the weight, head circumference, all that kind of stuff of your child. They report to you how your child compares to other children of their age by reporting a percentile. So if you are in the and let's just do a very specific example. My daughter has a height in the 98th percentile. So if she has a height in the 98th percentile, then she is taller, okay? Means she is taller than 98% of children her age. Okay, so that's what it means to be in the 98th percentile. So you can imagine what we just were studying, the median, right? What percentile is that referring to? Well, that would definitely be referring to the 50th percentile, right? So we'll just make a little note that the median is equal to the 50th percentile. Now we have a procedure for calculating a percentile. We're going to rank the data from highest to lowest, or from lowest to highest. That's what we did for a median, so it makes sense that we would do this for any percentile. We figure out what k% of the sample size is. Okay, So if we're looking for the kth percentile, calculate the percentage of the total number. And then there's this kind of complicated thing here. And I'm not even going to read it because it's just much easier to explain in an example. But after the example, I encourage you to go back and read step 3, and then I think it'll make a little bit more sense. But it's just kind of not in the most user-friendly form. So let's jump straight to the example. All right. So we have the heights in inches of 12 adult males. Okay, and they want us to calculate some percentiles. Oh, and I can see I forgot one little thing, so I'm sorry, let me go back. Actually, let me just talk about it right here. The 25th percentile, or the first quartile, we'll talk about this, I think, a little bit on the next page, actually, of our notes. Yeah, we'll talk about this on the next page of the notes. But the first quartile is just another name for the 25th percentile. The third quartile is another name for the 75th percentile. We'll get into that more later, but for now I don't expect you would have known that ahead of time. So we're going to put the data in order, right? So looks like 65 is the smallest. We have a couple of 66s, 67, 68, two 68s. We have a 69, a 70, 71, a couple of 72s, and a 74. All right, so the 25th percentile. So what we want to know is how far into the data set is the 25th percentile. So I want to know what is 25% of, and remember we had 12, right? Now, a handy little reminder about kind of some algebra things that involve percentages is that if you need to remember how to compute that, remember that of means times. So I'm taking 0.25 times 12, and I get 3. Okay? So here's what this tells me. This tells me that the 25th percentile is the average, I should say is between, be an easier way to say it, the third and fourth data values. Between the third and the fourth data values. Okay, now this might seem a little bit strange at first, but I'll explain why we are going between the third and fourth data values. So between the third and fourth data values, if you're in the 25th percentile, we just explained how that should mean that 25% of the data is below you. And in fact, I can see right here that that is true, right? 3 out of 12 is equal to 25%. But then that should also mean that no more than 75% is above you. So 9 out of 12 is 0.75. So understand that if we picked the third value, right? If we picked the third value, then below me I would only have 2 out of 12, which is only about 16.7%, right? So 16.7% of the data set, that's pretty far away from the 25th. So in order to make it so that we are getting the 25th percentile like we want to go between so that we get to include this 66. And really, it's no different than the reason on the last page why we, or sorry, 2 pages ago, why we averaged the middle 2 when we had this even number for the median. So same thing here, when you make this calculation and you get a whole number, then you average that value in the data set with the next one. So for us, that would be 66 plus 67 over 2, which gives us 66 and a half. All right, 75th percentile, right? So we want to know what is 75% of 12. So 0.75 times 12 is equal to 9. So we want to average the 9th and 10th values. So the 9th and 10th values are 71 and 72. So 71 plus 72, we go partway between them, 71.5. Why are we going partway between? Because we want 75% below where we're at, and we want 25% above where we're at, but no more than 25 and no more than 75. So if I was to pick 72, I would have only 16.7% above me, but I really want 25%. So by going halfway between, that allows me to have that 25% above, 75% below. All right, finally, the 85th percentile. Let's do that one. So for the 85th percentile, we figure out what is 85% of 12. And so that gives me not a whole number this time. So whenever you get a decimal number, then you're just going to go up to the next value. Notice I did not say round. Okay, I did not say round because we're not rounding, because if you rounded 10.2, you would round down to 10. So you go up to the next value. So what we're going to do is we're going to use the 11th value. Use the 11th value, and that's easy to find. That would be 72 inches. So, okay, why is that? By the way, I should be labeling these inches. So why did we do that? Well, if I had stayed between the 10th and 11th values, then I would, if I calculated what's above being between these values, there would be 2 of those. And what's that? That's 16.7% being above us if we counted both the 11th and 12th values. That's more than the 15% we would expect when computing the 85th percentile. So in order to make sure we're not overshooting what's above or what's below, we're just going to go bump up and use that next value. Just use the 11th value. Okay, so just going back to this procedure, it says if the result in step 2 is a whole number, then your percentile is halfway between the value of the data in that A position, right? So that number you just calculated, and the A plus 1 position. So that's what we did in these first two. If the result of the step 2 is a fraction or decimal, and B is the next larger integer, then the percentile is in the B position. That's what we did here. 11 is the next larger integer, so we used the 11th value.